There we go.
It's a little warm in here.
Just not used to the schedule yet. Okay, we haven't started. We got another 5 minutes. I started recording too early. Oh, you want to say the thing again?
Oh, you're right.
There we go. Thank you. That'll do it. And it's rolling.
So, in Blackboard, there are homework problems that are assigned, and I give you the solutions. I'm not talking master set, I'm talking textbook homework problems. Thursday of next week, I need to write this up. we're gonna have a homework quiz. So HWQ2. And what I'm gonna do is there are basically 4 or 5 different types of problems. There's think and explain, plug and chug, and suddenly I'm blanking on the others. But there's different types. What I'm gonna do is I'm gonna take one question of each type, change the numbers, that'll be the quiz. So think and explain, think and discuss, here we go, plug and chug. Sorry? Two others then. It'll come to me at 2 in the morning, I'll give you a call at the time.
Does that mean it's gonna be a 5-question quiz?
It'll be at most 5 questions per chapter. So at some point, you're gonna have multiple chapters on the quiz, so, and we'll talk about that when we get there. I think chapter 2 doesn't have all 5 of the types, but it's whatever, yeah. So if you like surprises, you can walk in having never looked at them. I do recommend that you have seen the problems and understand the answers. All the questions should look familiar to you when you get in. The wording I'm going to use is going to be almost identical to what Hewitt uses, although I might change some things for clarification because sometimes Hewitt is a little bit vague, leading to multiple answers. But did you ask a question, Jasmine?
Yes, when you say the homework, is that something like the
Textbook.
computer or the test?
There are textbook homework questions that I'm going to use for an in-class quiz. I'll hand you the piece of paper, you'll answer it, and
Okay, so they're in here. So they're inside
The questions, if you look on Blackboard, under textbook homework questions, there's a list of questions that lists basically the possibilities of what I might ask you. The questions I'm gonna ask you will come from those, but I'll change the numbers. Yep, the 5th.
You don't have lab next week, right?
Correct. And we are all here. So, got master set due on Tuesday of next week, the homework quiz on Thursday of next week, and the lab that you're doing tomorrow is due, the next time we have lab, which will be due Friday the 13th. If you're superstitious, feel free to get it in early. Other questions? Yes?
Can you tell us what pages in the textbook that you're referring to in terms of?
Chapter 2 would be the questions at the end, whatever that would be.
Think and solve?
Think and solve, that was another one. Oh, yes, there we go. So you got think and solve, think and rank,
You can explain
think and explain,
and think and discuss.
plug and jug.
There's no fun there.
Okay, I knew it was missing something.
So not think and discuss.
No, think and discuss also, I mean, you look at the, if you open up the textbook homework problems at Blackboard, I break it down by each type. I take one of each type, change numbers if there are.
So one of each type.
And in terms of answers, I provide textbook answers to it. I also, for a lot of them, I have just absolutely stellar one-shot, no editing takes of sort of verbal solutions where I talk through them. And I probably should edit, but I did, so there. And so next Tuesday, when I start out with, are there any questions, that would be a chance to ask questions on those, or Master Set 2. Or if there are questions about Master Set 2, we can do those now. Any other questions? Before we talk about chapter 3.
Oh, do we do support force?
Support force is a normal force.
Okay.
Yeah, I think Hewitt does that because he thinks it explains it better, but I think support force is limiting. Yes,
So none of the stuff we discussed today should be on the homework quiz.
that is correct.
Gotcha.
It does seem a might want it.
Yeah, it's hard.
When I was over in Ardmore, there was something wrong with the thermostat. I couldn't adjust it at all, but it was really cold in there. I had to wear, during the summer, I had to wear sweatshirts for class. And I complained about it, and they said, no, it's the air conditioning. Can't do anything about it. And eventually I pulled someone in there, well, I said, hey, could you come with me? And I brought the person in there, and the person said, man, it's really cold in here. I said, yes. And she was able to get stuff done. She had more pull than I did. But so they fixed it. But there are times I'm thinking, I sort of miss that extra cold room. Okay. We have talked about vectors and scalars. Force is a vector. More specifically, or more generally, we've talked about there's certain words that automatically mean vector. So let's talk about some of those. The first word is position. Position is automatically a vector term, and the symbol, the shorthand symbol for it, it is a vector, so we'll have that vector symbol over it. But this is going to be an X, S, R, Y, or Z. These are the 5 most common symbols that are used. For whatever childhood reason, I tend to pick X. But typically X, Y, and Z, X is for horizontal, Y is for vertical, Z is for depth. But X really is whatever direction I say it is. But you tend to find in more general terms, they S or R are used. Now, definition. Where an object is with respect to the origin. Part of me was thinking, we've done the lab on this already, I'm just repeating stuff, but no, you have not yet. So, for example, when I say the origin, in a classic math class, it's where the x and y axes meet, or it could also be on a number line. A number line is just wherever 0 is. In three-dimensional space, it's, you pick some place and you're gonna call that 0 or 0, 0 or 0, 0, 0 or the origin, or you pick some reference. So let's say Columbia, South Carolina is our reference. And we're now in Winston-Salem. And I'm gonna simplify this and I'm gonna say it's due north. It's about 200 miles. If this is my origin right here, what is my current position? Or our current position?
0. 0.
Pardon? You said 0? No,
Okay.
not 0. Well, where am I with respect to the origin?
North?
Yeah, it's the whole thing. It's a vector, it has a magnitude and direction. Well, I'm 200 miles north. So in this particular case, my position, 200 miles north. All right, so position is where I am with respect to the origin. I said, let's just make the origin Columbia, South Carolina, and pretend that we are 200 miles due north of it. So my position, where am I relative to what I'm considering the reference? Well, I'm 200 miles north of where I'm claiming is the origin. Yeah. Doesn't matter how I got there, because, you know, this is my life's journey here. Leading up to that spot, my position is still 200 miles north, no matter what else I did. So, we're gonna get into an exercise for one-dimensional motion, where I'm gonna ask you, is position positive, negative, or 0? So you know that position is positive if you're on the positive side of the origin. It's negative if you're on the negative side of the origin, and your position is 0 if you're at the origin. So it is positive if on plus side of the origin. Now I'm going to get away with just direction with plus or minus or 0 if it's a one-dimensional problem. So what I'm going to do is I'm going to establish this is my origin right here. And I'm going to say to the right is positive. Do a quick check here. Why is to the right positive?
Because you said.
Yes. Your own notes, if you want to do it backwards or do it the opposite direction, that's fine. But I'm establishing this just so we all have the same answers. Because on the lab that you're going to do in about 2 weeks from tomorrow, there's a question in there about why is the position positive? Because someone said so. All right, so right now, is my position positive, negative, or 0?
Negative.
In unison, that would be really cool. That would have been absolutely spectacular. Try that one again. My position, positive, negative, or 0?
Negative.
Oh, that's much better. There we go. And now?
0.
And now?
Positive.
And that's the way the game is played. Questions about position? The next word, displacement. Displacement is a vector term. I don't know why I'm capitalizing it, but I guess I am. Displacement has basically two definitions that work together. It is either the change in position or where an object is with respect to the starting point. So, since everyone wants a graph, take a look at that graphic. So I got the classic coordinate system right here. There's my origin, where the axes meet, and I'm starting out here. This would be my initial position. It's a vector that is that length and that angle from the origin. This is my initial position, so I'm going to put a little I here for initial, x of I. And I'm going to erase that and write it so that it potentially is neither. This is x, it's a vector, and I for initial. Now, depending upon when you look at my stuff, sometimes I don't use subscript I use a subscript O, or 0. It's hard to tell which one I use. Just be aware that it means the same thing. Either O for original position or 0 for when time is 0. So I'm starting here. So picture I get a map of Winston-Salem sitting right here in front of us, and we arbitrarily pick some point to be the origin, and this is, so now that's where I am relative to whatever I chose to be the origin. I now go to here. So this is my final position, because again, position deals with where am I relative to my origin, so this is x final. So x was a little subscript F for final. But where I am relative to where I started, well, I started here, I ended there. This is my displacement. It is the change in the position. I start in this position, I go to that position, it's how my position changed. This is also where I am relative to where I started. So the symbol is just going to be the change symbol, the delta, in front of whatever letter you're using for position. So let's take our simplified map here. Yes. All right, so my origin, Columbia, South Carolina. Right now, my position is 200 miles due north. That's my initial position. It helps if I'm in the writing mode. And let's say that I live 50 miles. Let's do it so I can do the math more easily in my head. Let's see. 4. Let's say that after school, I go 150 miles west. So this right here is my final position. Because again, where I am relative to what I've decided is the origin. And so that would be 250 miles. And that angle right there is 37 degrees. Now, the 250 miles, Pythagorean theorem. The sine 37 degrees requires trig beyond the scope of the course. So, my final position, 250 miles, and an angle of, well, I need to somehow describe that. If I just said 37 degrees, that would make it sound like it's in that direction. So what is that angle? If it, from here to here, what is that angle?
90.
Yeah, that's a 90-degree angle. Hopefully I was off camera when I just did that. And then 37 degrees. So it's 90 plus 37 degrees, so I would write that as 250 miles and 127 degrees, and that would indicate, given the classic, 0 degrees in that direction. My displacement, though, would be I need all of it. And that would be another piece of it.
150 miles to To the right or to the left?
or west, given our argument here. So 150 miles, don't forget units. And then the direction, because it is a vector, west.
With the whole positive and negative thing, when it came down to position of the origin, would that have anything to do with anything?
No, position of the origin is a separate thing. So, since this depends upon where I am relative to my starting point, let's just go ahead and establish my starting point is here. Now, the convention of positive being to the right, if it's positive to the right for position, it's positive to the right for displacement. You don't change what's positive direction in the middle of the problem. I would strongly recommend against it. So right now, my position, positive, negative, or zero?
Zero.
Wait, are you talking about your origin?
My position,
It's
position deals with origin.
negative,
Positive.
Robert?
negative,
Negative.
Because, are you going from the origin?
yes.
Yeah, position is from the origin.
Oh. Okay, so negative.
I know, new vocabulary.
From the start?
I thought you were going from the starting point,
Position deals with where I am from the origin.
from the origin.
Displacement is where I am from where I start.
Okay.
So my position is
Negative,
Negative.
100 rounds, okay? My displacement is
positive,
Positive.
positive. Displacement deals with the starting point. Position deals with the origin. Now, life would be so much simpler if I just made the origin, made my starting point the origin, in which case they're the same, but I didn't right now. Now, globally, we do have a system for describing position. It's called latitude and longitude.